I'm Miss Janet. Today we are talking about vectors. In physics calculation, we should be able to distinguish between scalar quantities and vector quantities. Scalar quantities show the magnitudes and the unit. Volume and mass are examples of scalar quantities. For example, the answers of volume would be written as 10 m³. 10 is the magnitude, which is the size of the volume. m³ is the unit of volume. Vector quantities show the directions, the magnitudes, and the unit. We usually define upward direction is positive. Downward direction is negative. Right-hand side is positive, and left-hand side is negative, just like the rectangular coordinate plane. Displacement, velocity, and force are examples of vector quantities. For example, the answer of vectors would be written as plus 4 ms minus 1. The positive signs show the direction of the movement. In this case, the direction of the movement may be either in upward direction or in right direction. 4 is the magnitude. Ms minus 1 is the unit of velocity. Now we start with some examples. In the following diagram, the arrowhead represents the direction of the movement. In question 1, the arrowhead of 10 n vectors is pointing in upward direction, so it is labeled as plus 10n. The arrowhead of xn vectors is pointing in downward direction, so it is labeled as minus xn. In question 2, the arrowhead of 6n vector is pointing in left direction, so it is labeled as minus 6n. The arrowhead of the remaining vector is pointing in right direction, so it is labeled as plus 4n. The previous two diagrams showed how to label a vector in upward direction, downward direction, left direction, and right direction. Besides these four directions, a vector can point in slant direction. In this case, the vector can be resolved into two components at right angle. In the rectangular plane, the vector f makes an angle theta with x-axis. Vector f can be resolved into two components. The one which is parallel to the x-axis is called vector fx. Another one which is parallel to the y-axis is called vector fy. Vector fx and vector fy are perpendicular to each other. Then we can translate vector fy to here, so that these three vectors can form a right-angled triangle. Vector fx and vector fy can be considered as unknowns. To find vector fx, we have the adjacent sides and the hypotenuse. Cosines will be used. Cosine theta is equal to fx over f. So fx is equal to f cosine theta. To find vector fy, we have the opposite sides and the hypotenuse. Sine will be used. Sine theta is equal to fy over f. So fy is equal to f sine theta. Then we can go through some related examples. In question 3, the vector can be resolved into two components A and B. A and B are perpendicular to each other. To find vector A, it is pointing in the right direction. Plus sign will be used to show this direction. We have the adjacent sides and the hypotenuse, so cosine will be used to solve vector A. Vector A is equal to plus 2500 cosine 30 degree n. To find vector B, it is pointing in upward direction. Plus signs will be used to show this direction. We have the opposite sides and the hypotenuse, so sine will be used, and vector B is equal to plus 2500 sine 30 degrees n. You can try to label all vectors in question 4. Next, I will show you some examples with 3 or more vectors in different directions. There are 3 vectors, f1, f2, and 20 degree n in the diagram. We can label vector f1 and 20n first. They are already perpendicular to each other. Vector f1 is in left direction, so it is labeled as minus f1. 20n vectors is pointing in downward direction, so it is labeled as minus 20n. Vector f2 can be resolved in 2 components a and b. A and b are perpendicular to each other. To find vector a, it is in upward direction. Plus signs will be used to show this direction. We have the adjacent sides and the hypotenuse. So cosine will be used, and vector a is equal to plus f2 cosine theta. To find vector b, it is in right direction. Plus signs will be used to show this direction. We have the opposite side and the hypotenuse. So sine will be used. Vector b is equal to plus f2 sine theta. You can use a couple of minutes to label all vectors in question 6 and 7. Finally, I will talk about the resolution of rate based on an inclined plane. The rectangular coordinate plane is usually drawn in this way. When we deal with a question with inclined plane, the rectangular coordinate plane will be rotated and drawn in a new way. The x-axis of the rectangular coordinate plane will be drawn parallel to the inclined plane. If the surface of the inclined plane is rough, frictions exist between the box and the surface of the plane. Frictions prevent sliding of the box. In the diagram, friction is labeled as plus F. When a body is placed on the inclined plane, the rate can be resolved in 2 components A and B. Let theta be the inclination. Now the angle between the vector W and the vector A is also theta. Vector A is pointing downward, so the component perpendicular to the inclined plane is minus W cosine theta. Vector B is in left direction, so the component along the inclined plane is minus W sine theta. The box is placed on the inclined plane surface. The normal Western force exerts to balance the weight. The normal Western force is pointing upward, so it is labeled as plus R. Now you can use a few minutes to label all vectors in question 9 and 10. I hope this tutorial is useful for you. Bye bye.